After, after understanding the basic gates, okay, basic gates and or not, we will go for the Boolean expression, Boolean algebra. After that, after understanding the Boolean expression and Boolean algebra, we'll start understanding the concept of universal gate, which is NAND gate, NOR gate, and XOR gate. So first we'll understand what is a Boolean algebra, Boolean expression. So Boolean is nothing but the algebra defined by the George Boolean in 1854. And instead of using a normal algebra for the numbers, he has used a truth table, zeros and ones, which is we called as a Boolean algebra, to understand the concept of the digital logic circuit. Understood? So in order to fully understand this, the relation between the AND gate, OR gate, NOT gate operation should be appreciated. And that's why to understand the relation between different basic gates and or not, Boolean expression has been required. Okay, so there are different laws which we have to remember during the Boolean algebra. So Boolean algebra has its own set of fundamental laws which differ from the ordinary algebra. They are, so if you'll see, as I told you, a plus 0 is equal to a. So anything added to the 0 will be a. So whenever, so a plus 1 is equal to 1, because whatever is added to the high voltage is nothing but you will get the 1. A plus a is equal to a. As we have seen the OR law, in the 1 plus 1 is nothing but 1, you are getting the high voltage. Also, you will get whatever is the input. So a plus a bar is equal to 1. So a plus the inverse of a is equal to 1. That's how you have. So these are the three different basic laws of your OR laws. A plus 0 is equal to a plus 1 is equal to 1. So addition with the high voltage or high values will be getting the, you will get the high values. So addition with this with if the both the inputs are low, or with the whatever, if the both the inputs are same. So we have seen 0 plus 0 is equal to 0, you are getting 1 plus 1, you are getting 1. Similarly, a plus a, you are getting a plus complement of a is equal to 1. Yeah, so this is one of the OR law. Now the second law is AND law. So what AND we have seen is addition with any zero voltage will be getting 0. Okay, any in AND, dot product with any lower voltage will get the 0 value, lower voltage only. So here you have the a dot 0 is equal to 0, a dot a is equal to c, 0 dot 0 is equal to 0, 1 dot 1 is equal to 1. Similarly, a dot a is equal to a dot 1 is equal to a. It will not be 1, it is not. A dot a is equal to a. And then you have the AND with the inverse law. So it means that if you have 1 0, you will get 0. Correct? So you have seen it, 1 0 0 0 0 1 0 0 1 0 0 1 1 only, there is the 1 in the AND law. Similarly, a 0 1 0 1. So a dot a dot. So if you have the complement a and a bar is equal to 0. Clear? So that is the AND law. Now you'll see the NOT law. NOT law is nothing but the inverse of. So 0 is equal to 1, 1 is equal to 0. So if a is equal to 0, then a bar will automatically become 1. And if a is equal to 1, then a bar is equal to 0. So a bar is equal to a. Now there are another three different laws, which is nothing but the called commutative law, associative law, distributive law, absorptive law, and de Morgan's law. Okay. So let's start with commutative law. What is a plus b is equal to b plus a, or a dot b is equal to b dot a? It means that a1 plus 0 is equal to 0 plus 1. Both will give the same output. 1 dot 0 is equal to 0 dot 1 will be giving the same output. So that is nothing but a commutative. Now you have associative law. Associative law means a plus in parenthesis or in bracket b plus c will also be equal to a plus b. If you change the bracket also, you will get the same value. A plus b is plus c. So break bracket also, if you shift, it will doesn't make much difference. So a plus b plus c is equal to a plus b plus c. Next is a dot. Similarly, as OR product or law, you have to apply the same thing for the AND law. A dot b dot c is equal to a dot b dot c. Okay. If we have multiple inputs, if you have more than two inputs, so if you have a plus b plus c plus d is equal to, all will without bracket will also give you the same output. Clear? So this is nothing but called the associative. Now distributive law is, if I have the one input and if I want to distribute separately, whether I'll get the same output. Yes. So if I have the combination of or and law together, whether I'll get the same output? Yes, you have to apply the distributive law. So here you can say A dot B plus C. So B plus C will be, if I'll take one term and A dot, it means that A dot and law is applied over here. So it will be, if I'll distribute A over both the sides, what it will be? A dot B plus A dot C. Yes, it will give you the same output. Next is A plus B dot C is equal to A dot C plus B dot C. Again, it will give you the same output. Again, here A plus A bar B is equal to A plus B. How it came? A plus A bar B is equal to A plus B. How? Anyone? A plus B. So here, if I have so if I have to take here out, what I can take this out? Can I call this one as A dot B A bar? And with respect to that, I will get A plus B, A bar will be, A bar will be cancelled. Clear? Next one is A plus B dot C. So again, here you have to distribute A. So A plus B dot A plus C. That also is possible. And then that also will give you the exact answer and equivalence. Now you have the absorptive law. These are all the laws you have to remember to solve, get the final crunched output, like single output. So when you solve the AND gate, OR gate, or NOT gate, you will get lot of output, multiplication, division, keep on happening if you have multiple gates. Then at the same time, you have to apply the laws so you can find out, okay, at the end, what will be the single output I'll get. So that's why you have to apply the Boolean algebra in that. So absorptive law is nothing but A plus A dot B is equal to A. If I'll take A common, what will be left? 1 plus B. 1 plus B is nothing but anything in OR law. 1 plus B. 1 plus 0 is nothing but 1. So that's why it was getting A. Similarly, A dot A plus B is equal to A. How it will be? A dot A plus A dot B. A dot A is nothing but 1 dot 1 is 1 A, and then A dot B. So 1 dot Z B, it will be nothing but 0. So because of that, you will get only A if you have two terms like this. Okay. Similarly, A dot A bar plus AB is equal to, you get AB. So this is what absorptive law works. So now again you have the De Morgan's law, which is nothing but A plus B is also equal to. So it's De Morgan's theorem says that if the AND law is equal to OR law, it means that A plus B is equal to A dot B. Similarly, A dot B is equal to A plus B. So we are going to see some of the problems as well, and then proof of that particular laws in a descriptive manner. So just take an example. If you have AB plus C, AB plus D is equal to AB plus CD, you have to prove this law. So how it will be? Just break the bracket. So AB dot AB, okay, then AB dot D. Yes, are you getting me? Okay, then plus C dot AB plus C dot D. Okay, now AB plus AB dot AB is 1 dot 1 is 1. AB is there. ABD, let it be ABD. There is nothing you cannot do right now with ABD. Then this will write at ABC and CD. Okay, now if I'll take what is the common between these two terms? AB. Okay, let's take AB out. So it will be remain 1 plus D. Here also, if I let it be like this only. Okay, so here I have given the example 1 plus A is equal to 1. Similarly, 1 plus D will remain 1. So 1. So this will become AB plus ABC plus AD. CD. Correct? Here again, I'll take out AB out. So it will become 1 plus C, and let it be CD will remain C. So 1 plus C, again, I'll apply the formula 1 plus A is equal to 1. So I'll get what I'll get 1. So it will be AB plus CD. So now can I take anything common? No, both are different terms. So I cannot apply this term. So this is my final answer for this. And now this can prove that, okay, I hence prove that LHS is equal to RHS. Here. So what is the advantage? What are the advantages? So we'll solve some more other problems in the next class. So before that, we'll see what are the advantages. So if we use Boolean algebra for your logical problems, you can save more gates and more operations. You don't have to make many AND gates, many OR gates, many NOT gates and all. You can just make some compact design. Yes, you can be design, and then it will be more simple and comprehensible, more serviceable. Okay, and then logical steps quickly can be repeatable. What is some disadvantage? Obviously, if something advantage is there, obviously some disadvantage is also there, which can only arrive at direct result, not implied ones. Hope you can understand. Can only arrive at direct results, not implied ones. Okay, with this we'll finish today's class, and then next class we'll be seeing some more problems with the universal gate concept and further more concepts. Okay, thank you.